So hello everybody and welcome back to my YouTube channel and आज का है हमारा part 4 in biostatistics whereby we will be discussing about one way and two way ANOVA. So अब हमें ANOVA यानी F test उसकी ज़रूरत क्यों पड़ी? So whenever there we need to find the differences in the mean between two or more different groups, तो हमारे T और Z तो थे वो two groups के लिए use हो सकते हैं, one group के लिए भी हो सकते हैं, मगर दो से ज्यादा ग्रुप्स के बीच में if we want to identify the difference we use the word ANOVA, that is analysis of variance, and there is another term called MANOVA, multivariate analysis of variance. So इसका validation जो है हम post hoc analysis से करते हैं, post hoc analysis. Now this post hoc analysis has different tests like Bonferroni's test, McNemar's test, that is related to Wilcoxon as well. Then we have HSD, honestly significantly difference, and LSD, least significance difference, LSD, HSD. So these are the tests that can be used as post hoc analytical testing for statistical testing for MANOVA or ANOVA. So that is the significance of ANOVA. Now speaking about the different types, one way and two way. So in two way we consider the rows as well as the columns, so the treatment as well as the blocks, but in one way we only consider the treatment, which is the column group. Okay, so whenever you're doing and performing the ANOVA, mostly we use it nowadays on softwares like SPSS, Minitab, R Online, statistical tool. These are few of the softwares, SAS, IBM, Institution of Business Management, and also we use these softwares for performing ANOVA. But when we talk about our theoretical part, so we need to solve it by a hand. So for that we need to know certain terminologies like SST, SSC, SSE, CF, DOF, MSC, and MSE. Now what are these terminologies? SST stands for sum of square of total. SSC stands for sum of square of columns. SSE stands for sum of square of errors. You can also call it as SSR, which is sum of square of residuals. CF is a correction factor. DOF is a degrees of freedom. You would have learned about this in T testing, where I had shown you how to take out the degrees of freedom. MSC, which is a mean square column, and MSE, which is a mean square error. In our two-way ANOVA, there are two extra terminologies: SSR, that is sum of square of rows, and MSR, which is mean square of rows. Okay, so you need to be familiar with all of these terminologies before we begin. And there are certain assumptions of ANOVA. So these are many a times asked as a theoretical part. So ANOVA, all the observations are independent, all the variances are equal, the population is a normally distributed. So that is, these are the major bases we can see, or the prerequisites for ANOVA to be used, or a Fisher's test, which is a F test, because it was introduced by Fisher. Okay, so now how do we calculate the correction factor and all of these things? Okay, so for the correction factor you need to do nothing, simply add all the different population that is given the data set, square it, so grand total ka square upon n. Okay, so suppose if I have a table like this, okay, so now this is 3 plus 2 5 6, 6 plus 3 9, 9 plus 2 11, 11 plus 4 15. So my grand total is 15. So I will do 15 ka square upon n. How is then, how many number of observations, or we can say number of data sets, the number of individual population that is sample, we have 6. So 15 ka square upon 6, that will be my answer of for correction factor. Once you take out this correction factor, उसको side में रख दो, ठीक है, आगे हम इसे use करेंगे. Now we have to take out the sum of square of column. Okay, so now this is suppose treatment 1 and this is treatment 2. So the column 1, iska you have to take out the this thing, you have to take out the total addition. So it will be 5. 2 plus 3 plus 1, you need to rearrange. Okay, so firstly, if this kind of data set is given, you need to rearrange this kind of data set. How do you rearrange? Treatment 1 and treatment 2 ऐसे ऊपर लिख दो. See, over here it's given horizontally, so you have to just arrange it like this. So treatment 1 mein what are the three readings? 2, 3 and 1, and over here it is 3, 2 and 4. Okay, so now this is column 1, this is column 2, this is row 1, row 2, row 3. So column 1 the total is 6, and here the column the treatment 2 the total is 9. Okay, so now 6 and 9, these are the sum of square of columns. So how do you determine sum of square of columns? So for that we need to do 6 ka square plus 9 ka square, that is the sum of square of column ka square, upon how many columns are there? It is 2, but you will not divide it by 2. You will divide it by the number that were added for making that 6 as a grand total. So how many numbers were added? 1, 2 and 3. So you will divide it by 6. सिंपली अगर ये लॉजिक कर तुम्हें कंफ्यूज कर रहा है, सिंपली रिमेंबर कॉलम को जितने रोज है उनसे डिवाइड करना है, दैट्स इट. सो इसमें रोज कितने हैं? 3 रोज है, राइट? सो सिंपली डिवाइडेड बाय 3. So this is major thing. Suppose now if there was one more column of treatment 3 and उसका total होता कुछ 8. So plus 8 का square. नीचे तो 3 ही रहता. Okay, बस एक column बड़ा है ना, row तो उतनी ही है. So now this is important. Okay, sum of square of column. But you will not directly, अब इसकी वैल्यू जो आएगी वो आप सब्सटीट्यूट कर दोगे घाई घाई में ना. ये जो CF निकाला है हमने, CF, you have to subtract it from this. Okay. So suppose iska SSC ka I'm just roughly taking, the answer is around let's say 40. Okay, and the CF ka answer is around let's consider just hypothetically it is 30. So you will get 40 minus 30, which is 10 as your SSC. Okay, similarly you have to find out the SST as well, that is sum of square of total. So for that what will you do? Simply add all the individual values. So 2 ka square plus 3 का स्क्वायर प्लस 1 का स्क्वायर प्लस 3 का स्क्वायर प्लस 2 का स्क्वायर प्लस 4 का स्क्वायर. Okay, so all the values over here, can you see over here? So I have added all the values ka square. In this will you divide it? No, in this you do not have to divide, you only have to subtract it by correction factor over here. So suppose iska answer I got as 50. Okay, so 50 minus 30, so 20. Your SST will be 20. Just remember, this is very crucial. Okay, so what did we do? Again I'll be repeating because it's a little bit intricate to understand, right? So for SST and SSC we have to find out these terminologies, right? So SST ke liye we just did an addition of all the individual data set and the square of them. So 2 ka square plus 3 ka square, and we subtracted it by correction factor. We did not divide it by any row or column. But in SSC we added the column ka total, squared it and divided it by the number of rows. So here the rows were 3 and subtracted it by correction factor. Okay, so this is very important. And simply now once you get this SSC, now SSE, the third terminology. How do you find this SSE? It is simply the subtraction of SST minus SSC. So we had got SST as 20 and SSC as 10. So our SSE will be again 10. Okay. Now for finding out mean square of column or mean square of errors, you simply have to divide SSC divided by the degrees of freedom of that particular. So column, how many columns are there? 2. So 2 minus 1, that is 1. Similarly for MSC, MSE के लिए the degrees of freedom is very crucial. Now remember, ऊपर तो तुम्हारे पास आ गया SSE, अभी निकाला आप लोगों ने ये वैल्यू, ये 10. लेकिन नीचे क्या करोगे? It will be number of readings minus the number of columns. So it will be SSE upon, we have 6 minus 1. SSE upon 6 minus, 2. We have 2 columns, right? Again I'm repeating, for a mean square column you have to simply divide sum of square of column divided by the number of columns minus 1. So SSC तो हमें मिल गया था, right? 10, and number of columns were 2. So 2 minus 1, which is 10 upon 1, which is 10, right? Now for SSE, What do MSE, what do we do? We have to firstly substitute the SSE ka value, which was 10. Then you have to divide it by the number of observations, which is 6, minus the number of columns, which is 2. So 10 divided by 4, which is 5 by 2. Okay. So this is how you determine MSE, MSC, degrees of freedom, SSC, SST, and SSE. Now let's quickly move on to the sum or a numerical that we will be solving, so that you come to know. And then you can make a table, like this kind of table. That I'll be showing it in the next slide probably. Okay, over here. Can you see? Sample 1, sample 2, sample 3. So here don't consider this as your column, okay? This is not your column. You have to either tilt the table, so like this it will be in the vertical position, or simply add in this way. Okay, so this will be your one column, because you have to determine the differences between the samples. Sample 1, sample 2, sample 3, not the differences between the individual reading of sample, right? So you have to add in the, if you are not tilting it, so simply add in this way. And if you are tilting the table, then you can that will be like horizontal, vertically you have to add. So now here we had got, see here, can you see the column square? So here we have 35, 25 and 30. So grand total comes to 90. So what will be a correction factor? Jaldi se bata do comment section mein, right? Grand total ka square, which is 90 ka square upon number of readings, that is 5 3s are 50, right? So 9 9s are 81, right, upon 50. Did you get this? Did you get this? So it can be around 550 or so, I think so. Just confirm it once. Sum of square of columns. Now this is correction factor. Sum of square of column will be what? 35 ka square plus 25 ka square plus 30 ka square. Divide. Will you divide? Yes, you will divide. Minus the correction factor. Now what will you divide it? Tell me. Quickly tell me. How many columns are there? How many columns are there? 3. But will you divide it by 3? No. I said you have to divide it by the number of rows. So rows कितने हैं? 1, 2, 3, 4, 5. Right? Rows कितने हैं? 5 है. So divided by 5. So this will give you the अपना SSC. Now SST के लिए what will you do? SST के लिए what will you do? Simply get the square of 9 ka square plus 7 ka square plus 6 ka square and so on and so forth up to the 6 ka square. Sabka individual square lena hai. Will you divide in this? No. Minus the correction factor. Minus the correction factor. This will give you SST. Now the third step, SSE. What will be SSE? SST minus SSC. That will give you your SSE. So here can you see they have found out SSE as 18, SSC as 10 and SST as 28. So SSE will be 28 minus 10, which will be 18, because SST is 28 and SSC is 10. And correction factor here they have found out 90 ka square upon 15. Did I mention the same thing? Yes. So it is around 540. Sorry, I mentioned 550. It is 540, right? Now you have to simply make this table. This table is very important. So number 1 will be serial number, then the variance. So variance is within the group and error and the total. So among the groups or within the groups or among the groups. Your degrees of freedom. How many columns were there? 3, and 3 minus 1 will give you the degree of freedom. SSE. How did I tell you to find SSE? Simply number of readings minus the number of columns. K is represented for K is representing columns. So 15 minus 3. And a total will be 15 minus 1, because n minus 1 simply, that means n minus 1. So SSC is 10, SST is 18, SST is 28 and SSE is 18. Now MSC will be mean square column will be SSC upon DF. MSE will be SSE upon DF. So it will be 10 upon 2 for MSC, and it will be 18 upon 12 for MSE value. Okay, so MSC and MSE you can find out by this way. Now once you have found out, you have to simply get to the inference. So for inference, you have to see the tabulated value and the calculated value, right? So the calculated value that you got over here is 3.33. 3.33 is your calculated value, remember. Now for tabulated value, that is 3.89. So that you have to observe from the table. Okay, you will be observing this value from the table. How do you observe it from the table? Simply see at 2 and 12. Why did we choose 2 and 12? Because MSc ka degree of freedom is 2 divided by the numerator. This is numerator, right? And the denominator ki degrees of freedom is 12. So 2 and 12 pe you have to check in the table. Now I will be showing you the table and in some time so that you can get an idea. But before that, this is your homework. You can solve this sum and let me know in the comment section what answer did you get, and we can cross verify. These are the 3 samples. So here they have given in the vertical position. So you will add in the vertical position. So it depends that whatever way you're comfortable with. They have found SSE, SSC and SST. They have made the table DF, SSC, MSS, F test 1.06 and that is their calculated value. So the tabulated value is 3.68. So whenever our calculated value is greater than the tabulated value, we reject the null hypothesis. What did I tell? Whenever our calculated value is greater than the tabulated value, we reject the null hypothesis. So will we reject in this case? No, because our calculated value is less than the tabulated value. So we will accept the null hypothesis. We will accept the null hypothesis. I was looking out for the table. Just give me a moment. I have mentioned that table somewhere. Yeah. So this is the table. Can you see? So what did I tell you all in that one case where we had got answer as 3.33 and 3.89, right? In our first question that we solved together. So what did the numerator degrees of freedom it was? 2, and the denominator degree of freedom was 12. So 2 pay 12 pay. We have to see. Can you see 3.89 over here? Yes. Jadoo? No, nothing is Jadoo. Everything is statistics. So our calculated value was 3.33 and the tabulated value is 3.89. What will you do? Accept or reject the null? Jaldi jaldi se comments mein type karo. Yes, you will accept the null hypothesis. Why? Because our calculated value is less than the tabulated value. Similarly, if I told you that the new MSc degrees of freedom is around 12 and the MSE degrees of freedom is around 14. So what will you do? Numerator is 12, that is sum of square of column ka degrees of freedom, and sum of square of error ka is 14. So 2 pay 12 pay 14, right? Can you see here 2.53? So this will have been your answer. So this is how you calculate values for one way ANOVA and two way ANOVA. I hope you all did learn and enjoy while reading. And if there are any doubts or you all want to make, you all want me to make a video on any particular topic, feel free to let me know your doubts in the comment section. Thank you so much everybody for watching the video.